Welcome to Honors Geometry, Lesson 2.6, two-column proofs. We just spent some time in 2.5 with algebraic proofs. Now we're going to move it to the geometric realm and make some two-column proofs. We'll have one column of statements and one column of reasons for those statements. So let's get to it. This is the format with which I expect you to write a two-column proof. You will put your given statements right up here, the statement you're trying to prove in this section, the picture or diagram that's affiliated with that proof right here, and then your statements and reasons. And when you write down your statements and reasons, I would expect you to enumerate them like this. And if this takes up some extra space, and this only takes up that amount of space, when you write your next statement, make sure that your reason is parallel with each number that way. Get it lined up correctly. So, givens here, what you're trying to prove here, picture here, list of statements, list of reasons. So let's go ahead and actually look at a two-column proof. Alright, and let's see here. Reasons. These reasons that you're going to list going down here, they can be a definition. They can be an algebraic property, which would also include reflexive, symmetric, and transitive properties. Let me get some more room down here for you guys. They could be a postulate. Again, a postulate is a statement accepted as true without proof. And you can also use a theorem. A theorem is a statement that is proven true. And I think those are about the only things that you can use for reasons. So any one of those might be a reason, definition, property, and if you can't think what it is but you know what it is, it's probably a definition. Alright, now I think we're ready to move forward. Let's go ahead and look at this proof. Go ahead and copy this down whilst I wait for you to copy it down, and then we'll move on and look at some statements and end up proving that ABX is 37. And I know you're going to just say, well, duh, it's obviously 37, but we actually want to make a formal proof of this. So let's go ahead and pause it while you copy down. Alright, be right back. And 3, 2, 1, we're back. Alright. Your first statement, usually a given, and so our first statement is the measure of angle ABC is 57 degrees. Oh yeah, I totally forgot. The other reason that it might be a reason, it was given to you. So we'll write given right there. Okay. Next statement, measure of angle XBC is 20 degrees. The reason, also given. So we have now used the two givens. Since there are no more givens to use, we have to look at the picture and see if there's anything else from the picture that we could possibly use. And I'm looking at the first part of the angle plus the second part of the angle equals the whole thing. And yes, that would be the angle addition postulate. We can come up with that just from the picture. So statement number 3, we're going to say the measure of angle ABX plus the measure of angle XBC equals the measure of angle ABC, because of the angle addition postulate. Wow, it's hard to read that right there. ABX, yes. The measure of angle ABX plus the measure of angle XBC equals the measure of angle ABC. Hey, I see this right here, and I see this right here. Hey, I bet we could substitute those in. And that's what is going on there. ABX plus 20 equals 57. Where the XBC was, we wrote 57. And where the ABC is, we wrote 20. Okay, so what reason? Substitution. And yes, I know I'm shouting by making all caps, but I don't want this to get confused with subtraction, so we'll just leave it like that. And speaking of subtraction, what can you subtract from both sides? That's right, you can subtract 20. The measure of angle ABX equals 37. What allows me to subtract 20 from both sides? Well, but of course, the subtraction property of equality. And there. Okay? This last statement will always be what you're trying to prove right there. It's always going to be that way. It's always going to work that way. The last statement that you make is whatever you're trying to prove. So why don't we go ahead and try one more proof. Let's move on to the next screen, and I'll pause it so that you can write it down, and we'll play around with the magic screen again and reveal things as we need to. So here goes the next proof. Alright, here we go. M is the midpoint of segment AB. We want to prove that AM is half of AB. And I know you guys are saying, yeah, that's obvious, Manning. But let's go ahead and prove this formally. Okay, we're going to start with the given. So our first statement is going to be M is the midpoint of segment AB. Why, you ask? Because it's given. Alright, there are no other givens to use, but I think we can follow the train of thought here. What do you know about a midpoint? Yes, that's correct. It does bisect that segment into two congruent parts. How do you know that? Because that's the definition of a midpoint. It bisects a segment into two congruent parts. So our statement is going to be segment AM is congruent to segment MB, because that's what the definition of a midpoint is. Alright. Now that you know that those two segments, or that you stated that those two segments are congruent, is there anything else you can say knowing that the segments are congruent? Sure. You can say that their lengths are equal. Why can you say that? Because that is the definition of congruent segments. That's why you can say that. And that's all the farther we can go on that train of thought using the midpoint, saying that the segments are congruent and then saying the lengths are equal. So now we're going to have to focus in on this picture right here. Is there anything that we can say about lengths with that segment that we haven't already said? Come on, you guys. We learned this early on. What we can say about that is using the segment addition postulate. The first part plus the second part equals the whole thing. And that segment addition postulate would be AM plus MB equals AB. Hey, look, we're getting closer to AM equals half of AB. We're getting really close to what we're trying to prove. Let's move it down just a little bit for a little bit more room. All right. Hey, guess what? We have AM equaling to MB. We have a couple equals. So I think I want to get rid of this MB, and I want to replace it with an AM since they're equal. And write AM plus AM equals AB. What allows us to substitute equals for equals? Oh, I just said it. Wow. Yes, substitution. So we can replace equals with equals. All right. 2AM equals AB. 2AM equals AB. What did I do? I added these two AMBs together. We'll just CLT that, combine like terms. And now we're just one step away. We want to get to here. And we have this. What can we do to both sides? Sure. AM is half of AB. We divided both sides by 2. And that would be the division property of equality. Thus we have AM is half of AB. We've proven it. This actually will conclude lesson 2.6 on 2-column proofs. Have a great evening. See you in the morning. And get ready to do a couple of proofs in class before you actually start your homework. Have a good one. Bye-bye.